Bienvenidos a esta Escuela AME. Yo creo que es imposible pensar en esta nueva era de ciencias de datos sin el input de matemática, de estadística matemática. Es una cosa realmente, es un tema realmente importante en el área, porque muchas veces vemos como el área de ciencia de datos realmente un área de ingeniería de cómputo, y los estadísticos siempre decimos, bueno, estamos haciendo lo mismo, están haciendo lo mismo en esta cuestión de ciencia de datos que hemos hecho por años. Entonces el input, la innovación y las cosas que hacemos en ciencias en estadística son necesarias en esta nueva era de datos, donde tenemos muchos datos masivos, donde continuamente coleccionamos un montón de datos. Tenemos que aprender a analizarlos, y evidentemente esto pone una nueva y completamente diferente estadística que tenemos que aprender y tenemos que formular para los académicos. Es un nuevo reto, es interesante, sin lugar a duda es un reto que estamos enfrentando todas las sociedades del mundo en estadística. En particular la Asociación Mexicana de Estadística ha tomado manos en el asunto, y en este último periodo hemos tratado de crear nuevas cosas para traer ese mundo de ciencia de datos, y no solo de ciencia de datos, también hay inteligencia artificial y otro tipo de cosas, ¿no? Pero la idea que llegamos en algún momento en la Asociación Mexicana de Estadística, la mesa directiva, era crear una manera de difundir. Uno de los objetivos principales de la Sociedad Mexicana de Estadística, la Asociación Mexicana de Estadística, es realmente diseminar, difundir, como decimos, y que se haga estadística en todo México de una manera correcta, ¿no? Por muchos años la asociación ha sido una asociación muy académica, y a pesar de que ha sobrevivido por más de 30 años ya, ha sido una asociación pequeña comparado con otras asociaciones de estadística en países más grandes, en países inclusive más pequeños que México. Por ejemplo, Chile tiene una sociedad más grande, Brasil es más grande que nosotros, pero tiene una sociedad inmensa, no se diga Estados Unidos, el Reino Unido, Italia. Entonces yo creo que el secreto está en pensar que no nada más es académico el asunto, ¿no? La estadística se usa, y se usa muy bien también en muchas otras áreas allá afuera del mundo académico, y parte de lo que pensamos en la sociedad fue de alguna manera crear y llamar la atención a esa comunidad. Uno de los movimientos que hicimos fuertemente fue cambiar el módulo que teníamos, el formato que teníamos del principal congreso de la Sociedad Mexicana de Estadística que teníamos en México, que era anual. Ahora lo hacemos de manera bianual, y las escuelas como esta, que fue una iniciativa que yo creo que tuvo muy buena respuesta, que estamos viendo aquí, la idea es que se haga de manera anual y que llamemos la atención de métodos estadísticos de frontera y de las cosas que realmente se usan en todo el mundo, traerles expertos para que de alguna manera puedan darse cuenta de lo que se está usando en todos lados del mundo. Esa es la idea, y la idea que hicimos ahorita, parte de la iniciativa de la sociedad para crecer también en su membresía. De hecho, una de las cosas que van a encontrar en sus paquetes de conferencia es una membresía gratis para un año, el año 2020, para todos aquellos que están participando en este evento. Y es una manera de llamarles un poquito a la sociedad, ¿no? Estamos creciendo en esa dirección, y a que se acerquen un poquito, que la prueben, y a lo mejor les guste y se quedan en el futuro con nosotros. Yo creo que es una cosa interesante. A mí, yo estoy particularmente feliz en ver la respuesta que tuvimos, primero por nuestros invitados, que son invitados que tienen una agenda súper ocupada, y la llenaron, y de alguna manera pudieron hacerse espacio para venir a México y darnos esta escuela. Realmente es una manera bonita de cerrar. Yo estoy cerrando con este evento prácticamente la presidencia de la Asociación Mexicana de Estadística. La paso al doctor Luis Enrique Nieto Barajas, que seguramente llevará un poquito de estas iniciativas más allá también, y tenemos otras iniciativas para crecer que todavía están en trabajo, ¿no? Bueno, hay muchas cosas que me gustaría decir ahorita, evidentemente. Una de las cosas que nunca se me puede olvidar es darle las gracias a toda la gente que participó en la organización del evento, a los patrocinadores que nos ayudan siempre con su soporte, en particular a la gente de RStudio, que también, además de ser patrocinador, hicieron el tiempo para venir aquí, a los organizadores, Michelle, Teresa y Enrique, y todos los demás ayudantes que de alguna manera pusieron este evento. Ya van a ver el ratito y van a ver que hicieron las cosas bien, estoy seguro. Yo creo que en ese sentido me gustaría invitarlos a que disfrutaran este evento de 3 días, que lo aprovecharan al máximo. Los invitados que traemos, yo sé que muchos de ustedes hicieron un esfuerzo para venir, pagaron una cuota, pero no se compara con las cuotas que de alguna manera cobran ellos en otros lugares del mundo, sea un esfuerzo también para traerlos, y la asociación también, y los patrocinadores también. Yo creo que es importante en ese sentido. Bueno, no quiero decir más, voy a cambiar a inglés para hacer la introducción de nuestra invitada principal. It's a pleasure to welcome Dr. Jennifer Bryan from the university. Well, she's an adjunct professor at the University of British Columbia in Canada. She's an expert and software engineer in RStudio, and I would say she's probably one of the best examples of how statistics has to be used in this new era of data science. She has contributed a lot with our packages, with excellent things. I use a lot of these Google Sheets, which is something she has put a lot of effort on. I can say many things about her. She did her Ph.D. University of Berkeley and in Biostadística, right? And then I realized that some of her papers are actually quite interesting from the statistical perspective. I went into it yesterday night, and they're really, really interesting. Although I think she diverted to computer sciences now, and more like our developer. I think is also an excellent researcher. I'm for sure missing a lot of things to say, but we are very happy to have you here, and I'm sure students and you will enjoy them as well as they will enjoy you. And then, well, welcome. Without further things to add, I would welcome and present Dr. Bryan for her presentation, Code Smells and Feels.
So thanks very much for the wonderful introduction, and also just in general, I'm really honored to be here and open this event and this first School of Data Science for the Statistical Association here. The projector and I are disagreeing about the aspect ratio for my slides. It's possible there's a way to fix this, but one of my attempts moved us in a bad direction, so I've retreated to here, so I'm sorry about that, but so things might be a bit stretched out, but I think it's still legible. I've given something very close to this talk once before as the closing keynote at USAR last year in Australia, and so I hope you don't dislike the fact that I'm giving it again. I think it might be my favorite talk I've ever made, and I really enjoyed making it, and I really enjoyed giving it. So I'm going to give a very close variation here. So if you go to this short link, rstud.io/codesmells, it'll take you to a GitHub repository. And on the README, you can find a PDF of the slides, and there's an annotated bibliography. So any image that I show or blog post that I mention, it's all linked there instead of packing all of those links and credits in the slides. And at some point we'll see a lot of code, and all the code snippets are there as well. And you'll see this short link a few times because I teach a lot, and I know the main question everyone has is, will these materials be available later? So the answer is yes. So as Ramses said, I've had a very strange and circuitous route to where I am today, and I started as a German major actually, and then I decided I couldn't really figure out how I was going to make a living as a German major, so I added an economics major as a pragmatic measure and spent a couple years in management consulting, which I enjoyed, and I learned a lot, but I also learned that I didn't want an MBA. And so then I eventually found my way back to grad school in statistics and became a statistics professor. I was a tenured statistics professor at UBC and did the wild and crazy thing, which was to leave and join RStudio full time, because I really decided I love writing code. And that's not true of every statistician. So I'm trying to speak to statisticians who don't love code as much as I do, but realize you do need to write it in a professional way and feel good about it. But one thing you'll notice is that, so my title now is software engineer, but I have no formal training in programming or computer science, which in fact is quite typical of people who make their living as software engineers. So you shouldn't feel bad about that. But so I've had to do a lot of learning on the job, a lot of deliberate practice and reflecting on what I'm actually doing to try to sort of self-teach myself and get better. And this talk comes from that effort. So statisticians in particular, I think most of us don't have much of a CS background. So when I was thinking of how I could back up this claim, I thought of this survey that Stack Overflow does every year of their users. And so I asked Julia Silge, who's a data scientist at Stack Overflow, for some advice on how to access this data set. So what I've ended up making here, I'm showing the ratio of the relative share of how many people who say they use R have certain backgrounds and people who say they don't use R. And so the red bars are majors, undergraduate concentrations or majors that are overrepresented in the R-using population. So not surprisingly, you see math and statistics and then lots of domain knowledge. And then you'll see the majors that are underrepresented in the people who use R on Stack Overflow is like everything where you actually get trained how to do computer programming. So computer science, computer engineering, software engineering, information systems, information technology, or system administration. So a lot of us are winging it when it comes to all of these topics. And if that's how you feel, you are very, very typical. And so the reason I like to give this sort of talk is at one of the very first USARs, I think it was the first, 2004, one of the members of the R core team, Martin Mechler, gave a talk called Good Programming Practice. I wasn't there. I had gone the previous year to the thing that happened before USAR, but I looked at these slides later, and this talk was a huge inspiration for me for many years because I felt like Martin talked about lots of things that we all need to do every day, but not many people teach you about. And it was this very holistic, pragmatic set of advice on how to work with R effectively. And so I'm trying to give a talk, and he's continued to update that talk over the years, and the most recent version was at ERUM, which is a European R meeting, in 2018. So I started preparing talks kind of along these lines and also feeding on my experience as an instructor. And I've given lots of talks on creating a sane workflow for yourself. So organizing your work, organizing it into projects, using version control, that sort of thing. And so this is, I think of it as like an installment in a series, the Code Smells and Feels talk. So we won't be talking about workflow here, but it's supposed to be this type of talk where you feel like you walk away and you feel a little bit more competent, like that your head is better organized about how to approach your code. So this is how I think of the process of getting better at something. The pictures that I chose are inspired by an interview with a journalist, an American journalist called Ira Glass, who creates a program called This American Life. And he wrote about his process at getting better as a journalist. So once you decide you want to do something, and you want to do it well, and you start really pouring yourself into it, there's this long period of months or years where you can appreciate the beauty of this hedgehog cake, but yours looks like this. And so your taste and your judgment developed very, very quickly, but it takes much longer to develop the ability to consistently execute at that level that you know you want to be at. And this is a very frustrating thing. So I think it's just important to acknowledge that reading lots of other people's code, reading lots of other people's advice, can sometimes give you this constant feeling of inadequacy. But so you need to push through that and realize that's completely normal. And there's something beautiful here too. People can still eat it. And one day your cake will look like the one on the left. So this brings me to my specific topic. So I made this really strange leap from being a statistics professor to working full-time on Hadley Wickham's team at RStudio. So we look after, I recently computed this, it's about 100, north of 150 R packages that you know as the tidyverse or rlib, the DevTools verse. There's a very large set of packages that about 10 of us maintain. And two other members of the team that I interact with a lot are Jim Hester and Gabor Shardi. So these are three people who do actually have quite a bit of formal programming and a considerably more experience than I do. And so they review my code, I review their code, we talk a lot about code on Slack. I read a lot of their code, I've started to take over maintainership of some of their packages. And at some point, I just start to realize that my code doesn't smell always like their code. And I think theirs smells better, often. So what is it? What is it about that? And you don't want, so I think one thing I really noticed as a professor supervising students, it's great when students have this sort of inner judgment and standards, and they're constantly applying those and increasing the quality level that they're shooting for. And so I wanted to identify why my code smells different so that I can work on it myself and I don't always have to be told, oh, I'd rather see it done this way. But that can be hard to bootstrap for yourself. If you knew to do it that way the first time, you would have done it, and so it feels very circular. So I read a lot of blogs, and I certainly keep my ears open on Twitter for software engineering methodologies and just ways of thinking about things that are going to be useful to me. And so I heard the term code smell, which is actually not invented by me, it's an official term, and it delighted me because it's super evocative that you can't really say exactly what's wrong with something, but you're like, it doesn't smell good. And it comes from a book called Refactoring, which I think just came out in a second edition by Martin Fowler, and I think he co-created this term with Kent Beck. And so a code smell is defined as structures in code that suggest or scream for, they say, refactoring. So what is refactoring? Refactoring is anything you do that makes your code easier to understand, cheaper to modify, but doesn't change its behavior. So this is not the topic of my talk, but I hope that people who are package developers and people who work with R as script writers can both get at this. But so the without changing behavior is really important. So if you're a package developer, you really aren't allowed to refactor things unless you have tests that are making sure your code does what you think it does. And then as you tinker and refactor with things, if you still pass your tests, you have some degree of certainty that you haven't actually broken anything. The interactive analyst often does this sort of eyeball-metrically, which is also fine, where you change your script to sort of clean it up, and then hopefully you're still getting the same results, but with nicer code. So if you want to improve your own coding skills, and you don't have time to go back and do a degree in computer science, I'm also not sure that a typical degree in computer science teaches you this sort of stuff that well, because I've also started to get the sense that a lot of other things are emphasized more heavily than things that come up once you're really doing software engineering on the job. But so these are the kinds of advice that I have felt trapped between. So lots of people will share binary prohibitions with you. And these are two I sort of believe in. So never use attach. I'm not a big fan of attach. We could talk about that at coffee. And always put spaces before and after an equal sign. Okay? But those are also incredibly narrow and superficial pieces of advice. So the never use attach, I think, is good advice. But there are very few times in your day where that's the piece of information that helps you move forward. It doesn't help you make many decisions. And even though I have opinions about your code white space, I will completely acknowledge it does not matter in terms of how your code executes. Okay, so it's just an aesthetic choice. And then you also have these really vague, high-sounding things people tell you to do, like to have taste. or to write more elegant code. And of course we'd all like to do that, but this is not at all actionable. There's nothing you can do to have better taste. You have to be told how to cultivate that taste. And so I think this idea of identifying code smells, and then once you've got one, applying the refactorings, live in this really nice intermediate space where they're not horribly specific and they're not just superficial white space recommendations. They actually mean something, but they're also really concrete. You can actually do something with this. And so there's this whole book and set of smells that are identified, and there are actually lists of suggested refactorings. And so sometimes this just helps you critique your own code in a fairly expert way, all by yourself. So we're about to take a quiz. So I'm going to show you a bunch of putative code smells because they have really great names. And you're going to have to identify each of them as being either a romance novel, a legal instrument, a quilt pattern, a movie franchise, or a Prince song. Okay, so here's the game. These are maybe code smells. They have really creative names. And I want you to sort of visit each one of these and decide if it's a code smell or one of these other things. So I'm going to give this maybe 2 minutes, and I would invite you to meet one or more people around you and discuss this with them, come to some joint decisions, or you can work through it on your own in your head, but in any case, let's pause here to do this. So hopefully you've had a chance to look through this list on your own, maybe discuss it with someone next to you. So we're going to work through these now. This is an audience participation part. So, what is too hot to handle? Is it? I can neither confirm nor deny that it could be a Prince song. I'm not sure. It is definitely a romance novel. According to Goodreads, it's a very tasteful book. I have not personally read it. So, all right, I have to do some research here that there's like ambiguity in my quiz. Primitive obsession is a code smell. This is one of the official code smells. I tell you, they have really evocative names, which is part of what makes them fun. Forbidden fruit tree is a quilt pattern. So that one was maybe kind of American-centric. I grew up in the South, where, I don't know, somehow my mom was really into quilts, so I saw a lot of these. When Doves Cry? Yes, okay. We've nailed that one. That one definitely is a Prince song. Inappropriate intimacy. This is a code smell. You would think it's a romance novel, but it is not. Fast and Furious? Movie franchise, yes. Restraining order? Legal instrument. Middleman? It is one of the code smells. So, part of what I like about these is they have these evocative names. It helps you remember that it's sort of an abstract general pattern that you can find. It also wouldn't feel mean to comment on someone's code with some of these because they're kind of silly. But I also think some of these that look like code smells but aren't could be. So if you can find the code, like I thought Fast and Furious would be a great way to describe code that's like hyper optimized for performance but is extremely difficult to read or modify. So it's very fast, but it will make you furious. So I think a lot of these could be made into code smells if you can find the right code snippet to illustrate it. So this is the actual list of code smells from the book. And I've highlighted a few, either because it's relating to the one I'm going to really talk about here, or because I like the name. So we're actually going to delve deeply now, for the rest of the talk, for the most part, into a chapter in this book, chapter 9, which is simplifying conditional expressions. So I want to talk about ways to write conditional logic. And hopefully you were warned that I'm like a very interested R person. So we're gonna now start working quite a bit with R code. I hesitate to ask this question, but how many of you use R? Okay, vast majority, so at least we're on the same page. And I think even if you don't use R, this should be applicable to other languages. And I had to pick one of these chapters to work through. I think this is the best one. But even if the conditional logic smell doesn't resonate with you, one of my meta goals for the talk is realizing that there's this whole world of thinking about how code is put together out there for you. And because I didn't have this formal training, often I would find patterns in my code, and it was just so gratifying to me to learn that, and it shouldn't have surprised me, that there are people who've been thinking about these things deeply, and you can read their blogs or read their books. And so this could also just be an example for you that there are lots of interesting ways to think about your code. So we're going to work with now, from here on out, with an example that I call Bizarro. And it's a function that we're going to write, and we're going to write many versions of Bizarro. So this is your second announcement of this short link, if you missed it before, but any code snippet that you see here is there, okay? So we have another audience participation break here. So instead of just telling you what Bizarro does, I'm going to show you some possible inputs on the left and the outputs on the right. So if you put minus 7704 in and apply Bizarro, it returns 770 minus 4. So let's take a short break for you to think about this, sort of digest it, and again, you're encouraged to talk to your neighbor if you're feeling friendly. I'll take about a 1-minute break. Okay, so hopefully what you're converging on is that Bizarro takes a variety of inputs and gives you the inverse, some definition of the inverse or the opposite back. Like that's really all you'd be able to glean from this. So if we put some numbers in, it seems to multiply the numbers by -1. If we put logicals in, it seems to do logical inversion. If we put strings in, it reverses the order of the letters in the string, and we will not actually code up the image version, but in this case it's inverting the image. So when you sit down to write a function in R, or I guess any language where you have a REPL, I usually start with just fiddling around with some top-level code. And on Wednesday, I'm actually going to join Our Lady's Mexico City, and we're going to talk about writing functions for a while. So my process does usually start with executing some top-level code. So let's start small here. We're going to assign 1, 2, 3, 4, 5 to x, and then this cat statement is going to create a string for us that says the Bizarro version of x is, in this case I want minus x, I execute it, and it says the Bizarro version of x is -1, -2, -3, right? And so often when you're playing with top-level code, you do this thing where you create different paths through your code by commenting and decommenting different lines, right? So while I'm still noodling around, I might play a little bit with the logical version. So I would comment that assignment out, I create a new assignment statement, run through this same thing, and I comment minus x out, and I say, now I'll do logical negation. So this is a good way to start writing a function, but you do not want to leave your code in this state where the way you create sort of different behavior and deal with different inputs is by strategic commenting and uncommenting of things. So tip number 1, since we're starting at the beginning, is do not comment and uncomment sections of your code to alter behavior. So I have found, I had almost 20 years of experience as an applied statistician who did a lot of collaborative data analysis, and I have a lot of R scripts on my computer. And every now and then you have one of those like zombie projects that comes back to life, you know, where like you did the analysis 5 years ago and suddenly the postdoc is like, we're gonna publish it. And so you go back and I have found actual analyses where the way I was generating 2 different figures was like this or something, and I hated myself because every time you need to comment and uncomment, and especially if you have to do it in a coordinated fashion in multiple places, you will never get that right, or at least you will only do it right like once. And then later when you come back to this code, you won't remember what you were thinking. So we're going to start improving this now. The first thing we're going to do is make use of everyone's favorite conditional logic approach in any language, if else. So instead of doing the commenting and decommenting here, we're going to say, if x is numeric, return minus x. If it's logical, return the negation. So we're only dealing with a few types of input now, but that's okay. So tip 2 is, instead of commenting, decommenting to create multiple paths through your code, use if else. But the whole rest of the talk is about the in moderation part. Usually people stop here and just apply more if else. And then if you are going to use if else, which comes up a lot, I think you should describe it in really grandiose terms. So I watched this Twitter conversation go by where people were complaining about all the sort of breathless AI machine learning hype, and that people will run logistic regression and they will call it artificial intelligence. So if you're going to do if else, the best description I've heard is that you can call it a 1-layer neural network with identity activation and no hidden layers. And you'll feel better about it. So now we're going to keep moving up this sophistication ladder, and we're actually going to write our first proper function. So Bizarro is going to be a function with one input, x, and I've just inlined the logic you already saw. So if x is numeric, I return minus x, otherwise logical negation. So again, I'm not ready to handle other input. Okay, this is pretty simple. And then I run Bizarro on my usual tests. So these are eyeballometric tests in a real package or something you would have formal tests. And I get back the usual output, so that makes me feel good that I have preserved behavior, but I'm starting to improve my code. So tip 3 is to use functions. You could come to Our Ladies on Wednesday if you want more about how to write functions and the process behind that. And then tip 3 is 3a. It's often better to write a few small functions than a monster function. So another thing I have found in my work, when I go back to it after 8 years of maturity, is sometimes I'll take what used to be a whole script and just shove that as the body of a function. And then you have what's called a monster function, because it does too much. And so you're constantly in the function itself, debugging it or testing it or trying to figure out what's going on. So generally breaking things into smaller pieces is a better idea. The Bizarro story is not going to allow us to explore this, but I couldn't help to give this advice. And then another piece of advice that was resonated with me but was a little bit of a surprise is that often a very small, well-named helper function is a better thing to leave behind in your code than heavily commented code, even if you only call this function once. And so that took me a while to accept. I used to think I could only write a function if I was going to call something over and over and over again. But sometimes it's just a way of sort of moving some fussy stuff elsewhere, giving it a human-readable name. And most of the time, all you have to look at is that name. And then only when you really need to look at the details do you go find the body of the function. Okay, so this is a new version of Bizarro. I'm going to give you a second to look at it, that has some things I like and some things I don't like. So it's pretty similar to the version that we just looked at. And I say if the first element of the class of x is numeric, or the first element of the class of x is integer, return minus x. Else, if the first element of the class of x is logical, negation, and then otherwise I'm going to throw an error. So the things I like here are at least the poor person who comes along and gives bizarro character input is going to get some sort of error message that's semi-planned. They would have gotten an error before, I'm sure. But what I don't like is this, these really ugly, hard to read conditions. And so I call this artisanal handling of class. So when you apply the class function to an object in X, you can potentially get a whole vector of things, like a data frame might have more than one class. And so this, taking that vector and indexing it to the first one is just a way of being super safe about it. But, so this works, and it at least returns an error when people provide unexpected input, but I don't like this stuff. So I'd rather see what we had before, which is numeric, is logical. This is so much easier to read. So when I go back in to work on code, whether I wrote it or someone else wrote it, like, this is a bad day, right? Because you're like, what were they thinking? What does all this mean? But if I just have to read is numeric, or some small well-named helper that they wrote, it's much easier for me to figure out what's going on. So that's why I've been doing that all along instead of handling class by hand. So tip 4 is if you need to do something different based on the class or the type of the input, there are functions for that. So in this case, is numeric and is logical are built into R. And they are always going to do a better job at writing is numeric and is logical than you are. Well, not always, but pretty much always. So use proper functions for handling class and use simple conditions. And then in this case, we were able to do both. And if you have really fussy condition logic about when you should go into this code block, maybe you should put that into a helper. So this is a wild-caught example of that. I have a package called Google Drive that helps people like move files onto and around Google Drive. And it has a copy function, drive, copy. And it's supposed to kind of work just the way CP would in the shell. We'll copy a file from one name to another. But the Drive API, for reasons beyond my control, will not copy a folder. And so before I go do this, I have to check that the file someone's asking me to work on is not a folder. But figuring out if a file on Drive is a folder or not is one of these like super fussy tasks. So I have to sort of look at its MIME type, and then there's this other thing called a team drive that's kind of like a folder but not really. And I don't want to look. I do not want to see that in my if statement. I'm not going to do that to myself. So I write a function called isParental, because in other places I need to use this to figure out, like, can I put a file in this thing? And that's what I use in my condition. And 99% of the time, I don't have to think about how I figure out if something's a folder or not on Drive, and I can just sort of read this code more easily. So here's our next version of Bizarro. We're going to keep making it nicer and nicer to work with. So now what I've done is I've used this function in R called stopIfNot. And it doesn't throw a great error message, but it throws a decent error message. And it's a really nice thing to put at the top of a function where you immediately check for hopeless input. And if you're getting hopeless input, you just get out fast. And it's a nice way to get that out of the way, and then you can write and read the rest of your function knowing that the weird stuff is gone. And so in this case, because I've only accommodated numeric and logical data, I check, is X numeric or logical? And if it's not, like, we stop now. And again, I run my same inputs, and I'm getting the same good output. And my error message isn't beautiful, but it's okay. So I usually use stopIfNot for internal developer-facing functions where we shouldn't throw errors very often. So I'm not worried about this hitting a user's eyeballs very often. It's usually my eyeballs that it will hit. So sometimes you can hoist types of input that should cause you to stop or return to the top of a function. And there's a name for that. That's called using a guard clause. And then the rest of the function is called the happy path, and that's also a term of art here. And it's nice to clarify and emphasize the happy path, knowing that you got rid of the weird path already. All right, so this is a big example, and it's different from Bizarro, but it makes a really important point. And I adapted it from a blog post. I think it's actually a C++ blog, but it doesn't matter. So this is pseudo R code. So let me walk you through it. It's super long, but that's kind of the point. This is more like the kind of code you actually find when you open someone else's project. So it's going to get some data, apparently. So if the config is okay, we move on. If I can write to the out file, we keep going. If I can open the network connection, I actually read some data. This is the first time I've done anything. So I've read some data. If the data makes sense, I'll beautify it, write it to file, and return. So that was the happy path right there. That was the now we deal with everything else. So if the data didn't make sense, we're going to turn false. Well, what is this about? Okay, if we can't open the network, we do this. And then each increasing layer here, it's harder and harder to figure out like what went wrong even. And so I think of these types of deeply nested functions, I feel like I'm peeling an onion. And sort of, especially as you get deeper and deeper into it, the code that you run in the else is getting increasingly farther away from the condition that tells you, like, how did we even get here? And so these kinds of functions are very, very hard to read, and it's really easy to introduce bugs here. So here's the second version that has exactly the same behavior, but goes crazy with this idea of hoisting any quick stop or return to the top. So if there's a bad config, just quit. Quit now. We're done. If I cannot write to the out file, get out. If I can't access the network, get out. Okay, now I have data. If it doesn't make sense, return false. Okay, it makes sense. Beautify it, write it true. So look at these side by side. They do exactly the same thing. They've got the same number of lines up to the fact that this is pseudocode. But if you have to maintain one of these or find a bug in one of these, you have a much better shot with the one on the right. And so here's something I want you to notice. I think of Yoda. There is no else. There is only if. So if you look on the left, every if has an else. And a lot of people think every if has to have an else. It does not. It does not. And over here, there are only ifs, no elses. So these are really extreme, and you rarely live in one world or the other. But my main point is, if the piece of code inside an if ends with stop or return, are the two main things, you don't need an else. You're out. And it means that you can bring everything below that one level higher, and it makes it easier to read. And also, in these sort of onion-y functions, the other metaphor I was thinking about this weekend is it's a bit like juggling. And every time you open a new if, you've like added another ball that you have to keep in the air, because mentally you're kind of keeping track of all these possible paths through the code, and you can't resolve any of them yet. And also, when you have really complicated if-elses, when you fall out the bottom, you have to think about all the different ways we could have gotten here. And so one way to really reduce the cognitive load of your code is to create these really linear paths through it if possible. And it turns out there's a lot of deeply nested code that doesn't have to be deeply nested. So now I'm going to create an acronym, and I really don't think this is a great acronym, and I don't think it's a great term, but it's just to make a point. So TMI usually means too much information, and I'm going to use it for total meat indentation. And I'm definitely not trying to make this catch on. It was just a way for me to point something else out about this code. So if you format your code and you're not an animal, every time you go one level in, you add one level of indentation, and you can argue about whether that's 2 spaces or 4 or 8 or it's a tab or whatever. But you go further to the right. So if you count the number of indentations over here, so also I picked the lines that I'm calling meat. Again, that's kind of subjective, but these are lines of code that actually do something. They're not just control flow, and they're not error handling. So if you look at the total number of indentations for the meat lines over here versus the meat lines over here, I've computed this ridiculous number for you. So there are 17 indentations on the meat on the left, and there's 1 on the right. And another ridiculous thing you could look at is the minimum meat indentation. So there is only, the highest level meat line on the left is already 3 layers in, and then on the right it's 0. We've hoisted a lot of stuff to the top level. So my main point with this is, again, if you're looking at your code and trying to figure out, well, is there anything else I can do about it? If you see a ton of important stuff happening with a lot of indentation, like that's a sign that you've built an onion. And there's no guarantee that you can unpack your onion, but you might be able to. And so here's another live caught example. This one also happens to be from Google Drive. So we're getting information back from a Google API in this case. And I have to look at whether we've succeeded in the task or not. And so what I wanted to show you in this example is sometimes you actually get out quickly for good things. So this is our general response processing function. So sometimes you get a status code of 204, which means good things happened, you succeeded, and there's no payload. So I just get out and I return true. And then all the other 200 status codes also mean success, but there's some data in the response. So I process the payload and I get out, I return. And then there's all the unhappy ways that this thing could have failed, all the other response codes, the 400s, the 500s. So then there's like 20 more really boring lines of error handling. But so sometimes you stop early and let the happy path unfurl. And in this case, I get out for the happy reasons first, and then I have my 20 lines of ugly error handling code. So it depends on which type of input you're working with. Sometimes it's handy to turn this whole mentality on its head. So tip 5, an if block that ends with stop or return does not need an else. So recognize those chances for early exit and to bring everything below 1 layer up. And that in general, like a weird aesthetic you can apply to your code is try to write it so that you need less indentation. Okay, so we're getting up the sophistication ladder a bit. Now we're finally going to deal with character data and a factor input. So we still have numeric is going to be -1 times x. Logical will be negation. So if I get character data, I'm going to reverse the characters in the string. So I wrote stir reverse. It's on the next slide, but you can probably trust me. And you saw it on the example. And then for a factor, I wasn't really sure what to do, but I decided I would reverse the levels. So something with level 1 will now be associated with what used to be level k and all the way back. You'll see an example. And then if something makes through all of there, then I stop. Okay, so now I'm handling a lot more input, so that's pretty cool. But if I apply my ridiculous indentation metric, my minimum meet indentation is not 0, and I usually want 0. I want some, if not a lot, of code at the top level. And you'll notice that all my conditions are basically checking the class of the input, okay? So this is where we go to sort of the maximum sophistication in this talk. Like, this is where you want to start thinking about object-oriented programming. So if your conditions all or mostly deal with class, it may be time to actually use proper classes and methods. And the CS jargon for this is called polymorphism. And so R has 3 methods for doing this: S3, S4, and R6, or reference classes, and then the implementation of that I use most often is called R6. Our group's policy pretty much is that we only use S3 or R6. And that's a very opinionated take. Lots of people use S4. In particular, Bioconductor is heavily built around S4 classes. And we use S3. This is an approximation, but use S3 if you can get away with it. So it's a very informal, sort of handshaky agreement, and it drives people up the wall who come from more formal programming languages, but it's very easy to work with because I'm going to be able to show you how to implement an S3 generic right now. So this is a little bit of a magical incantation, but now that I've realized Bizarro needs to take data of many different classes and do different things based on the class, to me it seems like Bizarro should be what's called a generic. And you deal with a lot of generics in R on a daily basis, like print and stir and plot, summary. These are all functions where we're used to using them on almost anything, and then it was somebody else's job to write the methods that do something sensible for different classes of input. And so this is literally how I usually go about writing a generic. The generic has to look like this. It has to take one X, often there's dots here as well, I won't get into that. And the body should be use method Bizarro. And then you write methods. And another thing that's weird about R is the methods belong to the generic instead of the methods belonging to the class. So now, the first method I usually write is the default. And so this is the code that's going to be dispatched if I haven't written anything else to handle that type of input. And so I'm going to say stop, like I don't know how to make a Bizarro whatever, and I get out. So this seems like a weird place to start, but if I define those 2 functions and I call Bizarro, I get errors across the board, which is what I expected. I haven't written any actual methods yet, but it's my error. So I know that like I'm driving this bus. And so I often do this sort of thing where I build something very simple and everything is stopping, but I run it and make sure that I'm getting my error message. And now I know that I'm in full control. So now I write the real methods. So this is all the same code you've been seeing, but where each of them gets their own little function, and again, the meat is top level. So the numeric method for Bizarro just returns -x. This function is so simple, it all fits on one line. I don't need any brackets and ifs and elses. Likewise for logical, character also fits on one line. I lavished 2 lines on the factor method, so I have to go in there and mangle the levels, and then I drop x out the bottom. And then I get, because I've saved so much space on the page and in my brain, now I have the excess energy to implement this for data frames. So for a data frame, we're going to apply Bizarro to the names. Names are a character vector. So that's going to come up here. And then I use lapply to visit each variable in the data frame and apply Bizarro to it. And that will dispatch the correct method based on whatever that variable is. But so this is like not a lot of code. I've written some pretty sophisticated behavior. That's what stir reverse looks like if you care. Okay, so now I get to use my new generic. So if I apply Bizarro to 1, 2, 3, 4, 5, I get the minus 1, 2, 3, minus 1, minus 2, as always. The logicals get inverted. The strings are reversed in order. If I take a factor with levels 1, 2, 3, mapping to January, February, March, now I get a factor with levels 1, 2, 3, but mapping to March, February, January. And then the coolest one is when I apply this to the iris data set. All the names have been reversed because they got the string method, the character method applied to them. All the familiar sepal and petal widths and lengths are negative now, and instead of seeing setosa at the top, you see virginica. But so, all of that was done with this. And so if you think about the sort of heavily nested, explicitly checking all the classes and packing all of that into one monster function, once you are willing to buy that you have to learn what S3 classes and methods are, but once you've decided that has to become part of your vocabulary, again, this creates code that's much more approachable than the big monster functions. So tip 6 is avoid a lot of explicit conditionals, especially if they deal with class, by creating methods and generics. Okay, so now we're going to close. We're getting close to the end, and I'm going to go out with an extravaganza of miscellaneous methods for addressing other ways conditional logic problems can present. So another function I think is incredibly important to know about in R is switch. And if you've written a lot of C or C++, you probably also write a lot of switch statements. And so what this does is it, again, takes the class, and you know I don't really like working with class this way, but we can look at the first element of class, and if that is logical, we do the negation. If it's integer or numeric, this is a little bit of a shorthand, we return minus x, and so on and so forth. So this actually behaves pretty much like some of the versions you saw Bizarro earlier. I don't love this code though, because I don't like working with class this way. So a nicer example of what I think switch does well, I pulled out of string_r. So string_r has a function called stir_pad, and it will pad a character vector so that everything is the same length. Number of characters, like so it looks good if you print it, for example, and it will pad on the left or the right or on both. So this is switch at its best. It takes a string and then dispatches different logic based on the string. So if someone wants to left pad, we call this function from the stringy package to put the padding on the left, and so on and so forth. So switch is ideal if you have a string, and then depending on what it is, you want to call different functions, for example. And you are allowed to write a helper function to generate that string. So sometimes your problem may not present as a perfect switch problem, but you can turn it into one. Here's another thing that comes up a lot. This is more in sort of the data wrangling world. So I have 6 imaginary people here and their age, 0, 4, 10, 15, 24, and 55. And I want to sort of recode that into a categorical data. And I could use cut maybe, don't worry about that. A lot of things, times you see people doing this. And so there's a function in dplyr called case_when that's really nice for this, that allows you, it sort of moves your data from the top to the bottom. So if the age is less than 2, call it a baby. If not, keep going. If it's less than 13, call it a kid. If not, keep going, so on and so forth. And it has a really compact way of generating this recoding. But again, I see a lot of people writing this sort of stuff with deeply nested if-elses, right? Which is another construct we have in R. And again, super easy to have mistakes here, and it's really annoying to find them and fix them. Whereas this logic is a lot easier to like quickly review and get oriented. So dplyr is very useful when you need to dispatch different data based on some data or logic. And then I'm going to show you this weird operator that we use all over the place inside tidyverse and rlit packages. When I first gave this talk, I didn't know what it was called, but I did know it existed in another language. It's called null coalescing operator. And it takes two inputs, x and y. You're going to see we call it as a binary function. And if x is null, we return y. Otherwise, we return x. And so it gets rid of a certain type of if-else all over your code. So here's an example of us using it inside DevTools. So usually, if we have an argument that's not required, again, we basically have a policy that we always assign it the default value of null. So we don't use missing very much. So we know if something's null that the user didn't send it. And so in this case, we can form the username value by consulting what the user sent. If the user didn't send anything, we check and see if they've set an option. And if that doesn't exist either, then we error. And I haven't written out the if-else version, but again, you'd be like 3 or 4 layers in deep if you unrolled all of this into explicit if-elses. And so it's a particular pattern that comes up a lot for us, is checking for a null and having basically a fallback value. So it's a really nice shorthand. Okay, so I'm going to recap some specifics, and then I have one kind of meta recap. So use if-else. If-else is great, but don't just apply more if-else to all of your problems. There are some other really cool things you can do. Keep your conditions simple, write small functions, don't do artisanal class handling if you can help it, and hoist those early returns and early stops to the top. And there's a whole world outside of if-else for ways of doing different things for different inputs, so that you could go full-on object-oriented code with S3, S4, and R6. Switch is a very simple function. You can often drop in. dplyr case-when is a great example, and this null coalescing operator. I should mention, it is defined in rlang package, and is re-exported by rlang, obviously, and also re-exported by per. So this is something I added since the Brisbane talk, because it's a blog post I read recently. So this is my last sort of meta observation. But I read this blog post recently called "Upgrade Your Cargo Cult for the Win." So how many people know the term cargo cult? Okay, not many. I didn't really know what it meant either, but I had heard it, and I assumed that it was just kind of like a content-free ad hominem attack. But so this blog post actually gave me in a paragraph what it was about. And so it's a term I think that mostly got coined a bit earlier, but it really got used a lot describing some things that happened after World War II. So both the Japanese and the Americans came to a lot of Pacific islands during World War II for their military operations. And a lot of the populations there had like no contact with airplanes and sort of modern technology. And so these two opposing armies would come in, build airfields, bring in all sorts of supplies, and then obviously a lot of that would end up being given to the native peoples because they were helping guide them or help people survive on these islands, and so they were getting goods they had never seen before. And so after these armies left, or navies probably, there were things that happened on some of these islands that got called cargo cults, where a really charismatic leader would maybe convince certain people that if we go through some of the motions, if we build airfields and we build airplanes, even if it's out of bamboo, or we build air traffic control towers, the cargo will come from the sky. And it's not clear whether they really thought it was true or sort of were taking advantage of something. But that's where the term came from, which I didn't know about. But so it's usually negative, meaning that you think you can go through the motions of something and cause a result without genuinely understanding it. But this blog post was interesting to me because it puts like a really positive spin. There is a way to put a positive spin on a cargo cult. And it's this idea that sometimes you have to, if you pick the right people or the right methodology, sometimes just imitating them works. And then you gradually learn why we do things the way we do. So an example of this would be if you have lots of nested if-elses and lots of indentation, even if you can't totally articulate why that's bad, you can still fix it, and then gradually, if you have lots of little things like that that you look for, gradually it does start to produce less buggy, more readable, more maintainable code. And the quote that really got me in this blog post was, "In doing, ability precedes understanding, which precedes representation." And his point was, a kid riding a bike has no idea what the physics are. And most of us to this day could not really describe the physics of why a bike works or why it's as efficient as it is, but we still ride bikes very effectively. And so I'm not advocating for superficiality, but if you choose well, sometimes just making your thing smell more like their thing is a path to producing a better product. And so a conclusion of this blog post is that if you choose your right community of practice, so the set of people that you sort of listen to and read what they're doing and chat with online and high-five each other when you get something right, or that you can work through when you have a problem, sometimes you can start with very sort of basic mechanical things and lift all yourselves up in a really meaningful way. And so with that, that's the end of my talk.